Hello, curious minds. Welcome to HQRS, where we explore the biggest and coolest ideas in science. Today, we're going on an incredible adventure. We're going to talk about something so tiny you can't see it, but it's responsible for making everything around you. Well, literally everything. We are talking about the famous, or perhaps the infamous God particle. So, imagine that you're sitting on a chair right now. Why aren't you floating away? Why does your pencil stay on the table? Why can you even feel your own body? The answer is mass. Mass is what gives things weight and makes them hard to move. But for a very long time, scientists had a huge mystery on their hands. Where does mass actually come from? For decades, we had a brilliant theory called the Standard Model of Particle Physics. Think of it as a universe's instruction manual. It listed all the tiny fundamental particles, the basic building blocks of everything, like quarks, that make up protons and neutrons, and electrons that zoom around atoms. It also described the forces that push and pull them, like the force that holds atoms together or electromagnetism that makes magnets work. The Standard Model was incredibly successful. It predicted particles that later we found, and it explained almost everything. Well, almost. There was one giant piece missing: mass. According to the early versions of this manual, none of these tiny particles should have had any mass. If that were true, everything, like electrons, quarks, everything that makes up atoms, would just zip around at the speed of light, never sticking together. There would be no atoms, no stars, no planets, and no people. Just a blurry, massless mess. This was a huge puzzle. How did these particles get their mass? That's when some incredibly smart scientists, including a brilliant man named Peter Higgs in the 1960s, had a revolutionary idea. What if, they wondered, the entire universe isn't just empty space? What if it's actually filled everywhere, all the time, with an invisible, energy-filled something that we can't normally see or feel? They call this invisible something the Higgs Field. Here is a fun way to think about it. Imagine the entire universe is like a giant swimming pool filled not with water but with super sticky invisible molasses. Now imagine different particles trying to swim through this molasses. Some particles, like the photon, which are the particles of light, are like a super fast swimmer who barely feels the molasses. They just zip right through without sticking, and that's why light has no mass and always travels at such speeds. But other particles, like the electron or quarks, are like swimmers who interact a lot with the molasses. They get sticky, they get slowed down, and they gather some of that molasses on them. This stickiness and slowness is what we experience as mass. The more a particle interacts with the Higgs field, the more mass it has. So, the Higgs field isn't giving particles mass like a gift. It's more like it's causing them to have mass by making them interact and stick to it. Every tiny fundamental particle has to wade through this cosmic molasses. So, the mass is an intrinsic property of each particle. This was a brilliant idea. But how do you prove an invisible field even exists? Well, just like when you excite a pond of water, you see a wave. If you could excite the Higgs field enough, it should create a tiny ripple, a particle of the field itself. This ripple, this particle, is what we call the Higgs boson, and finding it would prove the Higgs field was real. Finding this Higgs boson was the greatest treasure hunt in modern science. You needed to create immense energy, far more than anything we see on Earth naturally. So, what did scientists do? They built the biggest, most powerful machine humanity has ever created, the Large Hadron Collider, or famously called as LHC. Imagine a giant underground donut-shaped tunnel 27 kilometers long, buried deep beneath the border of Switzerland and France near a place called CERN. Inside this tunnel, scientists accelerate tiny particles called protons to almost the speed of light, literally 99.999991% the speed of light. Then they smash them head on, billions of times a second. Why smash them? Because Einstein taught us that energy and mass are two sides of the same coin. Remember E equals to mc square? By smashing particles together with incredible energy, you can create new particles from pure energy. Well, that's the theory. It's like throwing two super fast Lego cars at each other. You don't just get broken cars, you get a chaotic explosion of Lego bricks and maybe, just maybe, some brand new Lego creations form for a split second. We were looking for the Higgs boson in that Lego explosion, but the Higgs boson is incredibly shy. It appears for a tiny fraction of a second, then instantly transforms or decays into other particles, so we couldn't just see it. We had to look for its unique signature, the specific pattern of particles it decayed into. For example, it was like looking for a very rare type of splash pattern made by a stone thrown into a giant pond with millions of other splashes happening all the time. To do this, they built giant detectors the size of cathedrals like Atlas and CMS to act as cosmic cameras, recording every single particle that flew out of these collisions. For years, the LHC collected data, billions upon billions of collisions. Scientists around the world poured over petabytes of information. That's literally like millions of gigabytes. And then, on a historic day, July 4th, 2012, the world held its breath. Researchers at CERN announced they had found it. They had seen a consistent, undeniable signal, a specific pattern of decay that matched exactly what the Higgs boson was predicted to do. The probability of this being a fluke was incredibly tiny, less than 1 in 3.5 million. That's what scientists call a phi sigma discovery, a gold standard in physics. They found a new particle with a mass of about 125 gigaelectron volts. It was a monumental achievement. Peter Higgs, the man who first dreamed up the idea, was there, visibly moved. The following year, he and Francois Englert, who also developed the theory, were awarded the Nobel Prize in Physics. So, why is this so important? The discovery of the Higgs boson didn't just add another particle to our instruction manual. It confirmed the existence of the Higgs field, the invisible molasses that fills the entire universe and gives fundamental particles their mass. Without this field, there would be no mass. No mass means no particles sticking together, no atoms, no molecules, no chemistry, no planets, no stars, no galaxies, and no us. The God particle was truly the missing ingredient that allowed the universe and life itself to exist as we know it. Now, coming to the most important question, why is it named the God particle? Well, the term God particle was not coined by Peter Higgs, nor by CERN, nor by the scientific community at large. In fact, most physicists intensely dislike the name. The term was popularized by Nobel laureate physicist Leon Lederman in his 1993 popular science book, The God Particle. If the universe is the answer, what is the question? Well, I recommend you guys to read it. The original intent behind his title was actually a bit of frustration. Lederman initially wanted to call it the goddamn particle because it was so incredibly difficult and expensive to find. However, his publisher objected to the profanity and suggested the God particle instead. Now you know how the name has come, right? The Higgs boson completed our standard model. But in science, every answer leads to new questions. The Higgs discovery has opened up even more mysteries. Is it the only kind of Higgs particle? Are there other Higgs fields? Does the Higgs have any connection to other huge cosmic puzzles like dark matter or dark energy that make up most of our universe but which we still can't explain? Well, the search continues. The LHC is still running, smashing particles at even higher energies, looking for clues to these next great questions. The universe is an endless source of wonder, and the discovery of the Higgs boson reminds us that with enough curiosity, collaboration, and ingenuity, humanity can unravel even its deepest secrets. For more such interesting deep dives into high quality research in science, hit that subscribe button and stay tuned to HQRS. Thank you.